everyone, Sam from Developing Mathematical Thinking. In this video, we're going to look at one of our favorite tasks involving measurement, and it's a somewhat famous problem called the broken ruler. And I want to talk through some of the different misconceptions that kids have with linear length when they're measuring, particularly with a ruler. But this actually shows up in a lot of situations as kids get older when they start working on the coordinate plane. Shows up a lot with fractions on the number line as well. So we're going to just talk through what those misconceptions are and how to maybe remedy them with kids who demonstrate them. So the first thing I just want to share is the task called the broken ruler. And if we're supposed to measure the length of this red line segment, a lot of students end up saying that it's 7. So that's the first most common misconception. And that comes from just that's where the object you're measuring, that's where it ends on the ruler. So students aren't noticing that we're not actually starting at the beginning of the ruler, we're starting here at 3. So 7 is the most common incorrect answer. A couple ways to address that idea is first, just making sure that kids understand this idea that the 0 in a measurement is really arbitrary. It happens wherever you start is a 0 point. So I'm here at 3. And I'm actually at 0 units. I haven't measured anything. And a good way to model that is actually having kids stand up and count their steps as they take them, but don't let them count until their foot actually hits the ground. So they're literally iterating that full unit. Another way to help with that idea is to actually make sure that as they count, we say things like 3 and 1 more, that's 4. 3 and 2 more, that's 5. 3 and 3 more, that's 6, and so on. So that reference point of starting at 3 and counting 1 more, then 2 more, then 3 more, that will really help because if you just keep going on and on and on from where you started, they don't tend to think 3 and 2 more. What they're tending to think is if you go 3, 1 more is 4, and then instead of thinking of 2 more than 3 gets me to 5, young kids actually end up thinking just 4 and 1 more. So they're ending up just adding 1 to the previous measurement each time. So that's a couple of ways to help deal with the incorrect answer of 7. Another really common incorrect answer comes from kids counting the marks and not the full unit lengths. So you'll see kids do this all the time. 1, 2, 3, 4, 5. And that is one of the confusing aspects as kids start to transition to continuous measurements. Because up to that point, everything in their life has been what's typically referred to in later mathematics as discrete. So when you count on your fingers, there's no space, there's no measurement to count between 1 and 2. So a couple ways you can help remedy that issue is actually to make sure, just like with the stepping example I shared earlier, is to actually only count when you iterate the full unit length. So don't have them count spaces. And don't let them just point to the marks. Have them actually start here and say 1, 2, 3, 4. And you'll notice that I'm gesturing really intentionally to show that accumulation of measurement. That's a really new idea for a lot of kids. The idea that 7 is where we're ending, but because we're starting at 3, we're literally accumulating a distance between those numbers. Those numbers are not just these distinct locations. They're actually part of this ongoing measurement, the accumulation of those units. So that's one way to help with that. And then another one is actually backtracking a little and having kids build linear measurement tools. So building with cubes or chips or some type of physical object to actually iterate those units as you count. And then a really nice feature to kind of add to that once we built it is as they're counting, if it's something you can write on, literally marking out the unit lengths on the object with a marker or a pencil or something to actually show that's the part that we're measuring with, is just these lengths. A couple last tips just in general that will help with this idea. Starting at 0 when you count and then counting backwards. So kids get that sense of this stable, consistent order going forward and backwards. Those ideas can really help prevent the misconceptions that show up on the broken ruler.